Alright, let us start discussing unsaturated hydrocarbons. The first one is alkene. Alkene and alkyne we'll try to discuss together if possible. Let's see. General formula of alkene, CnH twice N. But here you have to remember N has to be greater than 2. It cannot be greater than equal to 1. It has to be greater than equal to 2. And for alkynes, it is CnH twice N minus 2. Again, same thing. N is greater than equal to 2. Structure, let us discuss for both. As you know, the carbon in alkenes are sp2 hybridized, so they have a trigonal planar geometry. There is one sigma and one pi bond between the carbon and carbon atoms, and the bond angle is approximately 120 degrees. Carbon is having S character 33.3% and P character 66.6%. And when we move to alkyne, there is carbon-carbon triple bond. The first alkyne I have taken C2H2, that is ethane, commonly called acetylene. The hybridization is sp with the bond angle 180 degree. There is one sigma and two pi bonds between the carbon atoms, and it's a linear structure. Here S character and P character both are 50%. I hope you remember last time while discussing hybridization we learned how to calculate the percentage of ferrous orbitals. Now let us discuss nomenclature and isomerism in alkenes. So you see, in addition to chain and pi position isomerism, which was shown in alkanes also, alkenes exhibit a new type of isomerism called Cis Trans Isomerism, that is coming under geometrical isomerism. Now what is Cis Trans Isomerism? You see, the carbon-carbon double bond, as you can see, there are out of 4 bonds of carbon, 2 are used in double bond, remaining two here, there are groups A and B attached here. Okay. Now if A and B are not same, make sure that A and B groups should not be same. If A's appear on the same side of the double bond, B's appear on the same side of the double bond, then such isomers are called cis isomers. On the other hand, if you have carbon AA and BB groups are oppositely placed across the double bond, then such an isomer is called trans isomer. For example, you can see here I have taken alkene with 4 carbons, and the double bond is between carbon 2 and carbon 3. So name of this particular compound is but2-ene. But when I see, you see the groups attached to this carbon 2 are different. CH3NH, here also CH3NH. So A group and B group, they are different groups. So both the CH3s are on the same side, both the hydrogens are on the same side. So it is cis isomer. Whereas here the same compound only I have written carbon CH3 group here on the top and here at the bottom. That means they are oppositely placed. So when they are oppositely placed like this, you can see they are called trans isomers. So name of this compound will be, complete name of this compound will be trans but2-ene. So let us go to the nomenclature part. So let us begin with N equal to 2. The molecular formula is C2H4 and the name of the compound is ethene. Eth because there are 2 carbon. Ene suffix is in because it is alkene family. Then we make N to be 3 and the molecular formula is C3H6. So we write the condensed formula CH3 CH double bond CH2. Name of this compound is propene. When N equal to 4, we start getting various isomers. The first structure we write CH3 CH2 CH double bond CH2. That means the double bond is between carbon 1 and carbon 2. Name of this compound is but1-ene. Now the question arises, can we have a geometrical isomerism for this? The answer is no. Because when I project the carbon-carbon double bond, when I write it in this form, you see the same compound I have written in this way by projecting the carbon-carbon double bond. What we need to notice that carbon 1, both the groups are same, hydrogen. So that means A is equal to B. So if A is equal to B, they cannot exhibit geometrical isomerism. Alright, because if I rotate it also, the structure will not change, it will remain same. Though on the other side I have 2 different groups, but this side I have same group. Hence, they cannot exhibit geometrical isomerism. Now, The second isomer is but2-ene, which I have already discussed. So one is cis but2-ene, another will be trans but2-ene. The third possible isomer is, I'm changing the longest chain, and I'm writing a carbon chain of 3, and the fourth carbon I'm putting in the second as a branch in the second carbon. So name of this is 2-methyl-prop-ene, 2-methyl-prop-1-ene, or simply 2-methyl-prop-ene. Now, will it be able to show geometrical isomerism? The answer is no, because you can check the groups attached to carbon 1 are both hydrogen, the groups attached to carbon 2 are both methyl, so they cannot exhibit geometrical isomerism. Now the question is, what kind of relationship are possessed between the various types of isomers? So you can see carbon 1 and carbon 2. In what way their names differ? The first structure but1-ene, second structure is but2-ene. So the difference is position. So they are position isomers. Whereas carbon 1 and carbon 3, if you check, carbon 1 structure 1, it is but1-ene, and structure 3 is 2-methyl-prop-1-ene. So one is but, the other one is prop. So they differ in chain length. So 1 and 3 and 2 and 3, they are chain isomers. And in carbon structure 2, we have, in addition to position and chain isomerism, they also exhibit geometrical isomerism. I have given you another example where n is equal to 5, molecular formula C5H10, and you can see the various structures possible here. Pent1-ene, where the double bond is between carbon 1 and carbon 2. Pent2-ene, double bond is between carbon 2 and carbon 3. They are position isomers because you see their word root is same, pent. Their word root is same, pent, but the position of the double bond is different. So the position is 1 and 2, so they are position isomers. The third so they also are capable of showing cis trans isomerism, though the groups here you can see, here I have CH3 and here I have H, CH3 and H, and this side I have C2H5 and H. So this is a cis form, and if I place them oppositely, they will form the trans form. So trans pent2-ene and cis pent2-ene are the two isomers of structure 2. Then we move to structure 3. I reduce the chain length from 5 to 4 and create a branch in carbon 2. So name of the compound becomes 2-methyl-but2-ene, and the various relationships you can find out, they are position. 1 and 2 are position isomers, already discussed. 1 and 3 and 2 and 3 are chain, and of course in 2 again we have cis and trans. Now we have another compound I have taken with 2 double bonds. Now if there are 2 double bonds in a compound, then they are called diene. Di because there are 2, ene because double bond. So here you can see I have numbered the carbon chain. You can number from either side, it will be same. The double bond is between carbon 1 and 2, another is between 3 and 4. So by rule we take the smaller number. So it becomes but1,3 diene. Now I am giving you discussing one problem given in your textbook, problem 13.7. They have given you the condensed form actually. You can see this is the condensed form given, and you have to name it. Alright. So for naming it, what we are doing, you can see here it's written CH3 twice. So I just split the structure. I write CH3. At carbon 2 there is another CH3. So, and then it's always easier to number the carbon chains. And you see here I have C2H5. This C2H5 I am splitting it. I am writing as CH2CH3. So I can see here the longest chain. The longest chain is having 10 carbons. So when the longest chain is having 10 carbons, so the word root will be decane. Okay, decene, not decane, decene. And I have 2 groups which is not part of the chain, 2 methyl groups as shown with the circle. So I have one methyl group attached to carbon 2, another methyl group attached to carbon 8. So 2,8 dimethyl. Then you can see there are 2 double bonds. One is in carbon 3, another is in carbon 6. So name of this compound will be 2,8 dimethyl deca 3,6 diene, or 2,8-dimethyl-3,6-decadiene. Either way you can name it. Similarly, I tried to explain number 2 also. They have given you the bond line structure. I have converted it to a condensed straight chain structure. There are 4 double bonds in this compound. One is between 1, 2, then 3, 4, then 5, 6, then 7, 8. So we have to take the smaller number. So name of this is 1357 octa, because there are 8 carbons in the longest chain. Since there are 4 double bonds, so we write tetraene. Tetra for 4. Now I request you to solve number 3 and number 4. It is from the textbook. Please have a look. And I'll also try problem 13.8 and 13.10 from your textbook. So that's all for today. We'll discuss the rest of the topic on next Monday. Wednesday is the test.